First, we need to connect this multi-circuit power meter to power lines of power supply. As the meter case is metallic, we are going to use 3 power lines concluding an earth wire. The terminal, 0.35, is PG, which is connected to the protective earth wire. The terminal 0.37 is L, which is connected to the live wire. The terminal 0.38 is N, which is connected to the neutral wire. Thus, power line connection is finished. Then let's connect the meter to voltage lines. These are voltage lines. The terminal 0.25 is UA, i.e., phase of voltage. The terminal 0.28 is UB, i.e., phase B voltage. The terminal 0.31 is UC, i.e., phase C voltage. The terminal 0.34 is UN, i.e., neutral line. Now let's connect the meter to the voltage lines, one by one. Now voltage line connection is finished. Next, let's connect the meter to the current lines. There are a total of 9 3-phase current circuits, and each 3-phase current circuit has 3 currents. That is that there are 27 single-phase current circuits. Thus 3 single-phase currents are also as a group. Let's see the first group of current lines. The terminals number 1, 2, 3, 4 are separately connected with the current lines, among which terminal number 4 is connected to incoming line of phase. A current, terminal number 3, is connected to incoming line of phase B current. Terminal number 2 is connected to incoming line of phase C current. Terminal number 1 is connected to the total outgoing line of the 3 phases. These are our 3 CTs. As you can see, the current enters in the direction of arrows. The red line is the dotted terminal. We connect the phaser first and put the line to connect with in a way. After connecting the 3 phases, we twist the 3 outcoming lines together and connect them to in. If the connecting lines of CTs are very long, we shall twist the 3 shield cable ends together and connect with the ground, as we are just making an example, so we don't connect to the ground now. Finishing the connecting of CTs, we need to get the cable pass through. The incoming line of the phase A should pass through the ring in the direction of the narrow. For the phase B and C, they are also the same. Then we finish the wiring. We check it again. If everything is okay, we shall start to power up the meter. Now we have finished the wiring of the power supply, the voltage, and the current of the first circuit. This is the current lines of the first circuit we have just finished wiring. This is the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, and the ninth. The wiring is the same with the first. Now we power up the meter. We can see the voltage display on the first interface with power on. We need to connect all the voltage and current lines if we were at the site. Now we have loaded 100 V of voltage and 1 A of current. We need to set a CT ratio on the meter, according to the CT's figure. The CT is a 30A, 20 mA type. Thus, we need to set the CT ratio as 30. Now, let's have a look how to set the CT ratio. Press buttons F and simultaneously. We can enter the password interface, and the password is 000. Press to get in. Next interface is the RS485 communication address display. Next is the serial port settings of RS485 communication. Next is the baud rate setting of RS485 communication. Next is serial port setting of the second RS485 communication. Next is the baud rate setting of the second RS485 communication. Next is the voltage wiring mode, 3LN, which does not need to be adjusted now. Next is the ratio of the PT. Next is the CT ratio. CT1 represents CT ratio of phase A in the first circuit. Because this meter can be used as a 27-circuit single-phase meter, Connecticut ratio of each phase in each circuit is settable. As mentioned, our CT ratio is a 30A 20 mA type, so we set the ratio as 30 here. Next is the CT ratio of phase B in circuit 1. We set it as 30 also. Then is the circuit 2, whose default is 1. If we set it as 30, we will need to press the button F to change the cursor, and press buttons F and Fe. To choose the figure, press to confirm it, and we'll move to the next interface of setting. We can finish CT ratio setting of all total 27 circuits here. After setting is completed, we can press buttons, Fe, and simultaneously to quit the setting mode, press to switch the main interfaces, i.e., the display interfaces. Press Fe and Fe to check the detailed figures display of a certain parameter category. For example, as for now, we see the voltage of phase A. Press Fe is the voltage of phase B, then the phase C. As we supplied 100 V to the meter, here the displays of the three phase are all 99 xV. Press. We can see the current. Here it displays 1 IA, representing the current of phase A in the first circuit. Press button Fe, and it will switch to the current of phase B, then the phase C. Press again and it will display the 2 IA, which refers to the current of phase of A, B, C in second circuit. As we haven't connected the second circuit, it displays 0. Continue pressing the buttons. It will display all the 27 current values. Press button. We can see the active power value. It displays the 1 Pascal, which refers to the active power of phase A in the first circuit. Press button Fe. It will display the active power of phase B, then that of phase C. Continue pressing the buttons. It will display all the 27 active power values. Press button, and we can see the reactive power. 1 QA refers to the reactive power of phase A in the first circuit. Press button Fe. It will display the reactive power of phase B, then that of phase C. Continue pressing the buttons. It will display all the 27 reactive power values. Press button. We can see the apparent power. 1 SAR refers to the apparent power of the phase A in the first circuit. It will display the power factor. Their switching modes are the same by pressing button Fe. Press button. It will display the active total energy, i.e. total energy of the three phases in the first circuit. Press button Fe. It will display the input energy, the output energy, then the total reactive energy, reactive input energy, and reactive output energy. Continue pressing the buttons. It will display all the 27 circuits, one by one. Press button. It will display as a single phase meter. 1 A refers to the energy of phase A in first circuit, then that of phase B, phase C. Continue pressing the buttons. It will display all the 27 circuits, one by one. Press button. It will get back to the first interface, the voltage display. Press to switch the main parameter categories, i.e. the display interfaces. Press Fe and Fe to check a specific parameter of a certain parameter category. Thanks for watching.